All right, the last major topic we're going to do is to introduce the concept of torque. We're going to do more stuff with torque in the next video, as well as and then look at how we use torque to solve problems, how we combine it together to use Newton's rotational second law. We'll then start to look at, as an example there, for example, of how we can end up understanding a not quite as magic pulley as what we had before. Then we'll end up looking at using rotational kinetic energy and just end up solving problems, and how that combines with rotational kinetic energy. We'll then, in terms of looking forward after that, we're going to introduce how we combine Newton's second law of linear motion with Newton's second law of rotational motion. The combination of those will give us equilibrium. And our last major topic is going to end up being angular momentum. So in terms of thinking of what's the big picture of what's going forward, that's what it's going to look like. For right now, for the concept of torque, that until this moment, we've never worried about where a force is. We've talked sometimes about where it only about, say, whenever we're talking about rotation, why a tire will go the way it does, that sort of thing, where it will be contacting at a point. But aside from that, we've never ever worried about where the force actually is, because it's in Newton's second law of translation. It makes no difference what part of an object the force is acting on. It's acting on the object here or there, wherever. If it acts on it, it acts on it. For rotation, though, where it's located makes a difference. So in order to understand this, if we end up having an object that would end up having a force acting on it, if it acts at a distance here, acts at a point here, we would end up saying that the lever arm is the closest vector from your axis of rotation to where the force is applied. So that vector will end up being called the lever arm for that force. So if the force is applied on the outside rim, it will be all the way out here. If the force is somewhere inside, it will be here, and so forth. So that's what we mean by my lever arm. It's the vector from the axis of rotation, right, where it would be rotating around, vector from there to where the force is applied. And then the torque is the cross product of the lever arm with the force. So in terms of understanding how that would work, if I've got then a force that I end up applying out at the edge of it, then this will end up being my lever arm, the distance from here to here. And then the force will be along the direction that I apply the force. So if I end up applying a force that's in this direction, I would end up pulling it like that. And you don't get a rotation, right? You don't get a rotation when you do that. If I end up having it at 180 degrees, this is my lever arm. So if I push it that way, I also get no rotation. However, that ends up coming in with the idea of my lever arm and my force. It'll be a cross product, and remember, the cross product is zero whenever the angle between this vector and my force is zero, or if it's 180. I get a maximum amount, though, if my lever arm and my force are perpendicular. So then I can get rotation easily when I do that. Whereas if I try to end up doing it at an angle, it will rotate. It's not that it won't rotate at all, but the rotation will end up being less, or at least a lower angular acceleration. So that's our basic concepts that we're ending up putting together for what torque is. And in particular, again, to understand the relative angles that are involved. And then we're going to end up doing a lot more with that later. One thing, though, I do want to end up pointing out, if you end up having some kind of an object that's spooled. So you have a cord, like a pulley, where you have something spun around here. You end up having the piece of wire that comes out here. The angle between where the wire is and the coil, the angle between where it's attached over here, sorry, the backwards thing, attached over here, to where it would spin around, that's always going to be 90 degrees. And you might end up, taking a look at some things like that. So if you have a toilet paper roll, nowadays if you have one, you're lucky. You have a toilet paper roll. You look at how the paper is attached on the end relative to there. It will be at 90 degrees. If you end up having a spool of thread, you end up pulling that out. You end up seeing the way that that's attached to the end to the vector from the center of the spool out to where it's attached. That's going to end up being 90 degrees. And that principle is going to be important whenever we end up putting together torques to understand how that relates to pulley systems, which is one of the things we're going to address in the next set of videos.